Let's take a look at this problem, but dealing with significant digits. The point A, right here, has coordinates in units of meters of 3 for the x and 7 for the y. And the coordinates of point B, right here, has units of 10 in the x and 2 in the y. You're asked to determine the length of the straight line from A to B to 3 significant digits. So the key is not the difficulty in computing the length, but to express the answer to 3 significant digits. So the approach would be to use the calculator to make the calculation of length, not worrying about how many significant digits are retained in any intermediate calculations, actually keeping as many significant digits, or at least 4 significant digits, in all intermediate calculations. And then at the end, round it off to 3 significant digits. So let's go ahead and do the calculations. We find that the equation for the length of the line will be the square root of the change in the x squared plus the change in the y squared. We find that the change in the x between 3 and 10 is 7, and that the change in the y is 5. So all you're doing is using Pythagorean's theorem to calculate the length of the hypotenuse, 90-degree angle right here. And we can substitute 5 squared, 7 squared, and we'll get that the answer is 8.602325 in units of meters. We want to express the answer to 3 significant digits, 1, 2, 3. We take a look at the 4th digit to see if it rounds or up and affects the 3rd digit. In this case, 2 does not round up, and so the length is equal to 8.60 meters, and that's the way we would express the final answer, having 3 significant digits. So in summary, when making calculations, keep your digits, especially in calculators, until you have the final answer, and then round the final answer to the appropriate number of significant digits. And in most cases, 3 significant digits is very common in engineering. Why? Because in engineering, typical measurements are only good to about 3 significant digits. Well, I hope you found that discussion helpful.